I am Nolan Kinigello, and for my experimental demonstration I chose electromechanical relays. Relays were invented in 1835 by Joseph Henry and were soon put into practical use by Samuel Morse to improve the telegraph. Relays are a simple magnetic circuit consisting of a coil with a soft iron core, yoke, and armature. They have a movable contact on the armature that changes connections when powered. Relays help where a smaller voltage or current drives larger ones, such as in a car starter, air conditioner, or other devices. Relays are also used in electromechanical computers, safety devices, contactors, and for amplifying DC signals. Ampere's law provided the theoretical basis for relays, since it relates the current in the coil to a generated magnetic field. Relays also rely on magnetic circuit analysis and energy conversion methods to find the force on the armature. The goal of this project is to create a working single-pole double-throw relay. We require many parameters to design one, such as those shown below. Using the parameters, we can derive the equation of motion for the armature with simple rotational kinematics. The only unknown is the magnetic force. We utilized FEMM with the following mesh and sections to find the magnetic force on the washer above the electromagnet. Simulating several gap distances allowed us to construct a curve relating the magnetic force to the gap between the magnet and the washer. Using the derived equation of motion and the magnetic force relationship allows us to use Euler's method to numerically solve the equations of motion to predict the behavior of the armature when the coil is energized and de-energized. The results indicate that the armature will take about 0.013 seconds to lower and 0.06 seconds to raise. Since the results indicate a feasible design, we construct the demonstrator according to those specifications. On the right, you can see the construction of our relay. On the left, you can see the setup of the demonstrator: an Arduino Mega, IR sensor, 5-volt power supplies, 5-volt relays, terminal blocks, indicator LEDs and resistors, and breadboards to house the components. And now we can see the demonstrator at work. First, we'll look at the 5-volt auto relay near the front. We'll toggle the state to normally open, and then back to normally closed. And we'll repeat it. We can do the same with our relay that we made. Toggle to normally open, back to normally closed, and again. But our relay can also serve as a telegraph sounder and replay some Morse code messages. That was hello. That was SOS. And this one. Is MAE ECE 535 really demo project. And finally, we have the relay just tapping out SOS in slow motion. Pay attention to the lights flickering. It gives a better indication of how the contacts flex on impact. In conclusion, FEMM and rotational dynamics allowed us to create a working relay. The simulation and analysis we performed helped to ensure that we ended up with a feasible design likely to work. As we saw in the video, the relay works as intended and serves a second purpose as a telegraph sounder. Thank you for watching.